Okay. Here we go. I think, did we do this one? I don't know if we did or not.
I can't see that.
Oh, God.
Oh, well, like I say, move back further a little bit more.
I was going to sit behind the cubby, but I forgot
Well,
there wasn't any seats.
To see it better, you need to, like I say, move back there a little bit more.
Yeah,
get
I
at
have
least
good
20
vision.
more
I can't see
feet.
it.
All right, let me move it up a little bit.
All in favor of getting zoomed in.
There. A business used straight line depiction to determine the value of Y, the value Y of an automobile over a 6-year period. Suppose the original value when T is equal to 0 is equal to 16.6, and that the salvage value when T is equal to 6 is equal to 4,000. How much has the automobile depreciated over 6 years? Okay, so suppose the original value when T is equal to 0, that's when it's coming off the lot, is the 16.6. And the salvage value after 6 years is 4,000. So how much has it depreciated?
A lot. So 16.6 minus 4,000?
Exactly. 16.6 minus 4,000. All right.
That's $12,600.
Yep. That's very true. There's several little things you learn here about cars, and one of them, as soon as you drive them off the lot, they depreciate. New cars is not what they're cracked up to be. Okay? All right. By how much is the value of automobile reduced at the end of, by how much is the value of the automobile reduced at the end of each of the 6 years? Well, you would have to find the slope there. So what we'll do is I'll write what we got. Let's see, we got 0 at 16,000. I'll write everything out first. We got a graph at 0 at 16,000. 16,600. And then we got at 6 years, we got it being 4,000.
12.6.
So you got a line that looks like that. Upside down. Oh, Lord. There we go. So there it is. So find the slope of that line. You got 1 point at 0, 16.6. Then you got another point at 6 and 4,000. Which way do we read?
Left or right?
So this is x of 1, y sub 1. This is x sub 2, y sub 2. Calculate the slope. Come on, y'all can do it. I have faith in you. Yeah, she can't get online. I tried. So M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is what? 4,000?
12.6.
Y sub 2 is 16,600. X sub 2 is 6. X sub 1 is 0. So that's going to give us a negative number, of course, over 6. And that's going to give us 16.6. What'd y'all say? 12.2?
12.6.
12.6? Okay. And that's, of course, what? 2, negative 2, 1, negative 2100. So pretty much at the end of each year, you're depreciating $2,100. Because 2100 is the what? Slope. And the negative means you're going from left to right, what? Downhill. That's what the little car is. A lot of people, again, you forget how to do this stuff. You forget that the negative slope is going down because you read from left to right. So you put your little car to left. And whatever it's doing, you go left to right. Remember what I said about playing with your phone and texting, please? If you're bored, leave. Okay? All right? Next question. What does it say next? It says something about prediction, doesn't it?
Priority 1 message coming in on secure
Okay, write the linear equation that models the value of S. So write the linear equation. So that means find a what?
Slope.
Find an equation. We just found the slope. Find an equation. So find an equation that goes with the slope. Find an equation that goes with the slope.
2100x.
What'd you say?
Would you just put 2100x since 2100 negative 2100 is the slope?
That's the slope. Yes, that's the slope. So you have a slope. The slope is equal to what?
Negative
2100. Pick a point. Which point you think I'm going to pick? Doesn't really matter, so unless there are two evils. I'm going to pick 6 and 4000. Now we have a point and what?
Slope.
We use the
Point
slope equation. What is the point slope equation?
Y minus y1.
Y minus y sub 1 is equal to m times x minus x sub 1. And you have a point of 6 and 4000. And you have a slope of negative 2100. So which way do we read?
Left to right.
Left to right. So this is x sub 1, this is y sub 1. Y minus parentheses equals parentheses times x minus parentheses. Plug and chug. What goes here? 4000, Hubert. That's right, class. What goes here?
Negative 2100.
Good job. And what goes here?
6.
Now simplify it.
Priority 1 message coming in
This
on
is a
secure
business
channel.
type question. This is the type question you'll see on some kind of GRE or some type of standardized test. So y minus 4000 is equal to negative 2100 x plus, well, that's going to be 12,600.
Yes, sir.
Y is equal to negative 2100 x plus 12,600 plus 4,000. So your final equation is y is equal to negative 2100
Priority 1 message coming
X.
in on secured channel.
plus 16,600. So if you wanted to find the rock bottom value of the car, where would that be? Look at your graph. Where would it be? Where it hits the x-axis, Hubert. That's right. So how would you predict that? Huh?
Come again?
How would you predict that?
That x equal to 0.
Well, yeah, x is equal to 0 or y is equal to 0 to get your x-intercept. So y is equal to 0 to get your lowest value. Then that would be 0 is equal to negative 2100x plus 16,600. So that's going to be minus 16,600 is equal to negative 2100x. And divide both sides by 2100x. And somebody tell me what 16,600 divided by 2100 is. Now you can use your calculators.
6.
What does it come out to be? Is it 6?
Negative 7.9.
What is it?
7.90.
Okay.
Negative.
No, it shouldn't be negative.
Should be positive because the
It
negative.
should be positive.
Oh yeah, it's a negative. They're both negatives. I don't see that.
So 2100 divided into 16.6 comes out to be what?
Negative 7.9.
It's 7.9.
Positive 7.9.
So your value of the car is worth nothing at 8 years. Now, this is where I show you a little bit of something. Anybody know the rule for buying a used car?
No, sir.
Used car rule. This is a Hubertism, so you can remember. Take the year of the car, subtract the present to get the age of the car. And then take the age of the car and multiply by 15,000, which is regularly used. And that's equal to a number. If you're buying a used car and that number is above that one, you need to walk away. If you buy a car and it's below that average, below that right there, then you probably have a good deal, unless somebody's mistreated. So that's kind of a used car rule for you to remember as far as the mileage of a car. Okay? All right. That's that question. Hopefully y'all learned something on that. You will see more questions like this. If you've got a homework question like this in your homework, you better do it 2 or 3 times. Hint, 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 hint. All right. Next question. Now this is 2.1. This is where we start chapter 2. This is linear. Okay, let's go into a little bit of a PowerPoint here for you to knock some cobwebs loose. Let's see. That's not what I want. I hate when I do this off. Right quick, I want to go into a little bit of order of operations. And y'all probably have heard this story before, right? See if you read it and see if you notice it. I don't know, I'm not doing the slideshow. There we go. Sorry. You ever heard of 3 guys going to a football game?
I don't think so.
3 guys stop at a hotel and get a room for $30 at night. Each guy chips in $10 for a piece of the room. Piece for the room. After they pay, in the room, the manager realizes he overcharges him $5. So he gives his son $5 to give to 3 guys. Son says, that won't work, I need 5 ones. Son starts to take the 5 ones and stops. Puts 2 in his pocket and gives each guy $1. So each guy really paid $9 for the room, right? Because they paid each $10, subtract the $1 that he gave them, add the $2 in the son's pocket, it's $29. Where's the missing dollar? I don't know how much money I've won off of this.
Message coming in on secured channel.
Especially in the Marine Corps, because I knew this before the Marine Corps. Won a lot of beer off of this. So some of y'all that invented math, tell me what's wrong with it.
I don't get how there's a missing dollar if he gave. So if the manager gave him $5 and he put 2 in his pocket and then gave $1 to each of the 3 guys, that's the $5. So I don't get how there's $1 missing.
I don't either. That's what we got. 27 plus 2 is what?
29.
The other dollar's in his pocket.
No, he didn't throw it on the ground. It's not in his pocket. He took $2.
Maybe the manager just kept
He
it.
put it in a trust fund.
He put it in a trust fund.
Yes, sir.
Okay, well, I thought I'd have 30. You are correct. What's your name?
Me?
No, not you.
I don't think
Can't
I'm
see
acting right.
anything. The one
The
on
girl?
the left, the lady that said that it should equal 25.
Savannah.
Anna, last name?
Savannah Porter.
Porter, Miss Porter. You're getting toward the right answer. The reason is we subtracted before we what? We subtracted before we multiplied. And you can't do that. Now, I'm going to show you something. Some of y'all have seen these on the internet or Facebook, and you've seen that people get the wrong answer, and it's really they get the right answer. They give you something like 3 plus 6 minus 4. Or 3 minus 4 plus 6. Or they give you something like, I can't think of one right now, but they give you one like 3 divided by 2 times 6. And have you seen some of these on the internet? On Facebook? If you're on Facebook, you've seen them. And people will there'll be like 100 replies, and there'll be 1, 15, 1, 15, 1, 15. The reason that is because people forget 2 of the simplest rules of mathematics. Now, some of y'all think y'all know the whole thing because you know, please excuse my dear Aunt Sally. Does that work 100% of the time?
No.
No, it does not. Make sure you write that down. No, it does not. It does not work 100% of the time. So, while some of y'all think you know everything, it
My
doesn't.
entire life.
Yep.
Tim does.
In mathematics, you have brothers and sisters. This is a Hubertism. You're not going to see this in any book. All right? The brothers and sisters are addition and subtraction and multiplication and division. Why are they brothers and sisters? Because they always undo each other. They're always fussing. They're always arguing the opposite of each other. Okay? Plus and minus, they always undo each other. Multiplication and division always undo each other. If you have brother and sister in a mathematical sentence, you go left to what?
Right.
Left to right. This one right here, people get wrong. People get this one wrong. 3 divided by 2 is 3 halves. 3 halves times 6 over 1 is equal to 3 times 6. Well, you can cancel. There we go. I always get 3 times 6 mixed up. There we go. Is 9. But if you do that any other way, well, let's see. Please excuse my dear Aunt Sally. 2 times 6 is 12. 3 divided by 12 is 3/12. So that'd be what? 1/4?
Incoming message.
Okay? Somebody's wrong, and I'm not. Okay? Because that's the way you're supposed to do mathematical sentences when you have brother and sister. And I guarantee you somebody in one of these 3 rooms have never seen that before as far as a rule of mathematics. Or they've forgotten it, one of the 2. if you have this, if you have 3 plus 4 minus 2 times 6, that you do left to right first. 3 plus 4 is 7. 7 minus 2 is what? 5 times 6 is 30. Okay? Not a lot of people remember that. So you got to make sure you remember that. What if you have a crisscross? Do what? What if you have a crisscross? Well, if you have a crisscross of brothers and sisters, you got cousins, right? You got cousins, you go to Aunt Sally's house. That means you use, please excuse my dear Aunt Sally. This is where I don't need to hit the student going, oh, well, I've never heard of please excuse my dear Aunt Sally. I've always heard PEMDAS. Shut up. Those kind of people irritate me. That's why I'm not married anymore. Okay? Those kind of people irritate the crap out of me. Oh, I never heard of I've never heard of that before. I've heard of PEMDAS. Shut up. I had a student tell me that one time, and I just ignored him. Because what is PEMDAS? Please excuse my dear Aunt Sally. Oh, but anyway, that's when you use please excuse my dear Aunt Sally. If you have a crisscross of the two. So if I give you something like this, this drives me bananas going back and forth. If I give you something like 3 divided by 4 plus 6. Well, automatically you say, well, I have cousins. The reasons I have cousins is because there's no brothers and sisters. All right, so do that one right quick. Just right quick in your head. Well, I see if Miss LeBlanc ever got on. No, she's still offline. I can't add you if you're offline. So what would this be? Well, please excuse my dear Aunt Sally. 3 divided by 4 is 3 over 4 plus 24 over 4. And that comes out to be 27 over 4. Okay? Now, the reason I have to go through this little bit of basic math is because when people get into equations and evaluation and determination of equations, y'all freeze up and you don't know what to do. So that's why I'm going over this little bit of basic
6.
math.
So he fix the fraction so
Just
he can add
equals
them.
6?
Yeah, like 24 divided by 4 is
Got to have a
6.
common denominator. Number one question I always get is where did 24 over 4 come from? Well,
That would be
6
6
over 1. So that's 3 over 4 plus 6 over 1. You can't add unless you have common denominators. So you got to make this a 4. You make this a 4, that's multiplying by 4. You got to multiply this by 4, which is 24.
I get it.
Yep. You remember that. The cobwebs are coming loose, right?
They're slowly getting knocked off.
All right. When you see the word, write these two words down, evaluate and determine. When you see the words evaluate and determine on a standardized test or a test, that's a 25-cent word for plugging in what?
Chugging.
Plug and chug. Always remember that. So if you're given directions, evaluate the following functions. X is equal to 2. At X is equal to 2. Y is equal to 4. Z is equal to 3. That means wherever you see something, you're going to plug those numbers in. And that's what that means. And that's why you need to know how to do order of operations. I'm not going to spend a lot of time on this. That's just for your information, for your standardized testing, because sometimes when you see the word evaluate or determine, you get kind of messed up. Well, you think of solving. No, you just plug and chug. And determine if the function is a solution. At the end, if you get 15 is equal to 15, is it a solution? Yes. Yep. If you get 14 is equal to 23, then it's not a solution. And again, this is basic math, a little bit of a refresher, but it shouldn't hurt some of y'all. Okay. And then you got to algebra. And then you learn the first step equations. And everybody in the class probably can do these 4 equations that's down at the bottom. I don't think anybody should not be able to do that. I'm not going to do the slideshow. I'm just going to do it from here. But that's not where people have the problem. Those 4 down at the bottom is not where you have the problem. Where do students have the problem with algebra?
Order of operations.
It's when you do more steps to those one-step equations.
When you put them all in there.
First thing, combining like terms. Second thing, distributive law. Third thing, clearing fractions. That first homework question that was sent out of chapter 2 is clearing fractions. So that means somebody has forgot how to clear fractions. Clearing decimals. That's the things that y'all suck at. Okay? Now, remember when you're talking about combining like terms, it's just like adding things up in the grocery store. 2 boxes of cereal plus 3 boxes of cereal equals 5 boxes of cereal. If you have X and you have X, then you just have a label of X. But what students do is they forget that when you add X's and subtract X's, it just is X's. They try to do the product rule or whatever. They try to start adding and subtracting, and you don't do that. You just, it's a label, just like tomatoes. 5 tomatoes plus 6 tomatoes equals 9 tomatoes. The label does not change. Same thing with the X's and the Y's. So when you combine like terms, it should be pretty simple. You shouldn't have to, refresh too much on combining like terms. And this is how you do combining like terms with an algebra equation. All right? 2x plus 3x plus 2 minus 7 is equal to 14. Well, before you do anything, you've got to simplify this by combining like terms. The 2x plus the 3x is equal to 5x. The positive 2 minus 7 is equal to negative 5. And now you've got an algebraic equation. And you bring the 5 over and you solve. Now, this is the number one thing that students forget how to do besides clearing fractions, and that is the distributive law. Now, most of you know how to work with concrete. Some of you might not know, some of you may know, I don't know, work with concrete. If you ever work with concrete, if you ever get a ring inside the concrete, you can't get it out after it cures. The only way you can get the ring out of the concrete is to bust it up with the hammer. Well, same thing with functions and equations. Your ring is the X down here. That's your ring. You can't get it out because this is a concrete block. That parenthesis is a concrete block. So you got to take that 3 and bust up that block to get it in pieces to where you can get the ring out. And that's what the distributive law is. So whenever you see a number outside of parenthesis, you know that you're going to have to use the distributive law because you can't touch what's inside those parentheses because it's a concrete block. So when you do the distributive law, it's going to be, okay, that's the last one there. Sorry, I ran out of that. Let me get out of here. So when you do the distributive law, you always distribute to get the variable by itself. 2 times x minus 3 is equal to 14. And then you distribute 2x minus 6 is equal to 14. 2x is equal to 14 plus 6. 2x is equal to 20. And x is equal to 10. And that's the distributive law. And people forget that you have to use the distributive law. And then usually after you use distributive law, what comes after the distributive law? Combining like what? Terms. Every time you distribute, probably your next step is going to be combining like terms. Now, what else do people forget? Well, people forget this problem right here. Well, I had it up. Pull it up again. People forget this one. So write this one down. It is 3/4 times x minus 1 equals 1 minus x over 8. Now, there's several ways you can do this problem, and I've got three, almost 4 degrees.
Mr.
I
McClure.
know all the different ways to do it. But the
You
reason
forgot the
I
other
teach,
X.
Mr.
What?
McClure, there's another part to the problem. It's 3 times x minus 1 over 4, and then minus x equals 1.
minus
x over
x equals 1.
Yeah.
Okay. Sorry. 3/4 times x minus 1 minus x
Yes.
is equal to 1 minus x over 8. Now, check that and make sure I got that right.
Yeah.
Okay. Now, I know there's several different ways to solve this. I don't need anybody telling me that there's another way to solve it. What the best way to solve it is the one that you understand the best. Okay? And that's to the person that sent the question, whoever that person is. That's the person I'm teaching to. The easiest way to solve this problem is to clear the fractions. So, I'm going to multiply through by the common denominator. Multiply through by the common denominator. Now, how many denominators do we have?
2.
2.
2. So you need to find the common denominator of 8 and 4. Well, the common denominator of 8 and 4 is 8.
8.
So I'm going to multiply by 8 over 1. I'm going to multiply everything in here by 8 over 1. So I'm going to put an 8 over 1 here, an 8 over 1 here, an 8 over 1 here, an 8 over 1 here. And I'm going to rewrite my problem. 3/4 times x minus 1 minus x over 1 equals 1 over x minus x over 8. So what's in parentheses, pretty much what's up here, okay? Now, what happens when you multiply through by the common denominator? What happens to all the fractions in your problem?
You
They
can't.
cancel out.
Cancel out. What's 24 divided by 4? 6. Minus 8x equals, okay, I messed up here. Oh, I didn't see, wait a minute. What? It's not 1 over x. It's 1 over
X over 1.
It's whatever.
Thank you. That's 8 minus x. Now look at there, isn't that nice? I'd much rather deal with this. Deal with this. All right, now finish it.
How's it 8 minus x? Would it just be 1 minus x?
8 over 1. Unless I did something wrong. I had 1 over x. I'm sorry. I messed that up. So here we go. 6 times x minus 1 minus 8x equals 8 minus x. Your first step is to what? Distribute. You've got to distribute. So distribute here. And that's 6x minus 6 minus 8x is equal to 8 minus x. 6x minus 8x is
Negative 2.
2x. Now, I want everybody to stop right here because I know that I'm going to step on some toes here, but there's somebody in here that says, oh, well, you got to take that negative x over to the left-hand side. No, you don't. Okay? For some reason, there's some teachers out there in K through 12 that like to teach that you've got to take the x's on the left-hand side and the numbers on the right-hand side. Well, that's a bunch of crap, because what if I was to hire you on my farm and I was to tell you I wanted you to feed my horses, and I have 2 buckets out there in the barn, and one of them is a 2.5 gallon bucket, and the other one is a 15-gallon bucket. Which one are you going to choose to feed the horses with?
The 15-gallon.
No, you ain't. Be quiet.
Uh-huh.
Why are you going to
2.5.
choose 15? Do you know what a 15-gallon bucket looks like?
No.
Exactly. It's about 3-4 foot high, and it's about this big around.
Well,
So
I
you're
can't
going
carry
to lug that 15-gallon bucket around full of feed when you can be lugging it around in a 2.5-gallon bucket.
I'm going to put it in the golf cart and write it down.
Yeah, just put it in the golf cart, whatever. Okay, well, Hubie's farm ain't got no golf carts, all right? So you're not going to use the 15-gallon bucket. You're going to use the what? You're going to use the
2.5.
smallest bucket. Which one of these is the smallest bucket? The smallest bucket is which one? Be careful.
-2x.
Negative 2x. So you're going to move it across. You're going to move it. And that becomes positive 2x. Now, the reason you always want to keep your variable positive is why?
You have to
One, it
divide
makes
it in.
the operation a whole lot easier. And two, when you're dealing with equalities, you won't have to remember 2 more rules. Now, if you like to remember math rules, knock yourself out. I don't. I can't remember a phone number. So I had problems remembering rule after rule after rule. So I made the math work to where I didn't have to remember the rules. And if you make the variable positive, -6 is equal to 8. What's -1 plus 2? Plus x. If you make that variable positive, you come out just as good. -8, -8. X is equal to -14. Okay? Telling me that you have to put 2x on the left-hand side is like telling me that you go into a park in Anderson and your son Jody and your daughter Susie sits on this side and this side. You go to another park in Clemson and Jody wants to sit on this side and you tell him, no, you can't do that. You have to sit on this side.
Will you put the paper up?
There, how's that?
Perfect.
Okay. Nope, Jody, you can't sit on the right-hand side of the seesaw. You always have to sit until you grow up and become an adult. You have to sit on the left-hand side of the seesaw. That's how you do that problem. Always keep the variable positive. So, to go over a rundown of algebra. 1. Always combine like terms first. 2. If you see parentheses in algebra, this is not numerical. This is algebra. Okay? If you see parentheses, you have to do the distributive law first and then combine what? Like terms. 3. If you have fractions or decimals, what should you do? Clear them. Then worry about the distributive law or the combining like terms rule. And that's your little bit of an Algebra 1, Algebra 2 review. Now I'm going to have to shut her down because some of y'all are going to self-combust. So let me go ahead and stop.